In this video, we're looking at Exam 1, Section 2, number 2A. And what these problems ask us to do is to compute the derivatives of the following functions and to simplify our answers. In number 2A, this is the function it gives us. It gives us the function... Oh, I don't like that color. I'm going to go and switch that. So it gives us the function y equals the cosecant of 3x over x plus 1. And we would like to find the derivative of this. The first thing I notice here is that this function is actually one function divided by another. In other words, this is like f of x over g of x, right? Where f of x is the cosecant of 3x and g of x is x plus 1. So when I look at this, I'm thinking I'm going to need to use the quotient rule. But it's not just the quotient rule, because f of x here is a little more complicated. It's not just one function, it's actually two functions. It's the cosecant of another function, the simple function 3x. So cosecant of 3x is the composition of two functions, and so I'm also thinking I'll need to use the chain rule. When I get to that part, I'll use the chain rule. So let's take a shot at doing this. I think I'll make for those of you who do not remember how to use the chain rule, or what the chain rule is, or how to use the quotient rule, or what the quotient rule is, I'll make some separate videos on those topics later. For now, I'm going to just use them, and maybe you can learn them from this example. So let's find this derivative, dy dx. So this is y, here's dy dx. dy dx of the cosecant of 3x over x plus 1. I remember the quotient rule in the following way. I say it's ho d high, so this is the bottom part, the ho. This is x, the quantity x plus 1, times the derivative of this numerator, the derivative of the numerator. So the derivative of a cosecant is actually a negative cosecant. In this case, it's of 3x, times the cotangent of 3x. But now we must account for the fact that there's a 3x in there by using the chain rule. So we have to multiply this by the derivative of 3x. What is the derivative of 3x? It's 3. Alright, so what did we write down? We wrote down this is the ho, this is the d high. So ho d high minus high d ho. Here comes the high. The high part is the part on top. So this is the cosecant of 3x times the derivative of the bottom part, the d ho. So the derivative of the bottom part, the derivative of x plus 1 is just 1. There's the numerator of the derivative. We'll come back and try to clean it up later. And this is all over ho. So it's all over x plus 1 squared. I just applied the quotient rule. I applied the quotient rule, but in this part I had to multiply by 3 because I also had to take account of the chain rule. Alright, well, let's see if this can be cleaned up just a little bit. This is a negative, and that 3, I can certainly write this as negative 3 times the quantity x plus 1 times the cosecant of 3x times the cotangent of 3x minus the cosecant of 3x times 1. Nothing changes. All of this is over the quantity x plus 1 squared. Not very much can be done to simplify this now. There is a cosecant in both terms. I would accept this answer. Alright, so here is our dy dx equals this.